Right, today's video, it's on the derivations of the R formula. Right, earlier we have learned the addition formulae, the Pythagorean identities, and the double angle formulae. So in this video, we'll learn how to solve equations of the form a sine theta plus b cos theta equals to c, or a sine theta minus b cos theta equals to c, or a cos theta plus minus b sine theta equals to c using the R formula. Right, so let's do the derivations to find the R formula for a sine theta plus b cos theta. So to begin off, let's let a sine theta plus b cos theta equals to R sine bracket theta plus alpha. Right, so we're going to apply addition formula to simplify the one that I've highlighted. All right, so the next step is that we're going to do a comparison of similar terms on the left with similar terms on the right. So in this case here, you can let a sine theta equals to r sine theta cos alpha. And why do we want to divide by sine theta on both sides? Okay, because there are two unknowns here that we have to find. We have to find the formulas for these two unknowns here. One is the r, formula to find r, and the formula to find alpha. So if I divide both sides by sine theta, on the right hand side, I will end up getting r cos alpha. And on the left hand side, I'll get a. So I will end up getting r cos alpha equals to a. I'm going to call this equation 1. Then the second comparison will be let b cos theta equals to r cos theta sine alpha. Likewise, I'm going to divide both sides by cos theta so that I would get r sine alpha on the right hand side, and on the left hand side, I will get the constant b, and I'm going to call that equation 2. Right. So I'm going to use this eliminations method, all right, to get rid of alpha first. So to do that, I am going to square equation 1, as in I'm going to square r cos alpha, and I'm going to square a. Similarly, I'm also going to square both sides for equation 2. So let's see what we'll get after squaring both equations. Right, so when you square r cos alpha, you get r squared cos squared alpha equals to a squared for equation 1. Then r squared sine squared alpha equals to b squared for equation 2. And what I've done in the next step is to group r squared cos squared alpha plus r squared sine squared alpha equals to a squared plus b squared. And you can see that there is a common factor here, which is your r squared. And common factor, we can just factorize it. And sine squared alpha plus cos squared alpha, you would be reminded of the Pythagorean identity we've learned earlier on, and that is equals to 1. So you will have r squared times 1 gives you a squared plus b squared. And because r is a positive value, we only take square root of a squared plus b squared. Okay, so we have the formula to find r already. Now the next thing is that what is the formula to find alpha? Right. So if you were to recall the connections, what connects sine alpha and cos alpha is a tangent alpha. So tangent alpha is equal to sine alpha over cos alpha. So I'm going to take equation 2 to divide equation 1. Right, so I end up getting tangent alpha equals to b over a, and alpha is tangent inverse b over a. So there's something that you have to take note of. R is a positive value. Alpha is also alpha is an acute angle. It's a positive value also is an acute angle. And your a and b are positive value as well. All right, let's do one example. All right, so we're going to let 4 sine x plus 3 cos x equals to r sine bracket x plus alpha. Right, so you're going to compare this with your a sine theta plus b cosine theta. Right, so from there, you can write down the values for a and b, which come out to be a equals to 4 and b equals to 3. Right, so what is the formula that we have derived earlier on to find the values of r? Yes, it's equals to square root of a squared plus b squared, and you plug in the values for a and b, and you get r equals to 5. And what is the formula to find out alpha? Yes, alpha is equals to tangent inverse b over a, which is tangent inverse 3/4, and that gives you 36.87. All right, the working degree of accuracy for angle in degrees is 2 decimal places, but the final answer will be just 1 decimal place. Right, so we're going to put all this together, and we'll get 4 sine x plus 3 cos x equals to 5, because we found your values of r to be 5, sine bracket x plus 36.87 degree. And we're going to solve it. Okay, because the second part of the questions require you to solve the trigo equation. All right, so to solve the trigo equation, first step is to make sine function the subject. So I need to take 4.8 divided by 5. That gives you 0.96. And to solve trigo equation, what is the first step that we do? Yes, to find our basic angle or the reference angle. And the symbol used here is also alpha. So sine inverse 0.96 gives you 73.74 degrees. The next step is to find the new range. And also from your ASTC, we can sieve out the quadrants where your angle X are hiding. So using ASTC, as we are dealing with the positive value for sine, the angle will come from the first quadrant or the second quadrant. So first quadrant will just be alpha itself. That means X plus 36.87. Remember, you're finding X plus 36.87 first. So equals to first quadrant, which is 73.74. Second quadrant will be 180 minus alpha. But that's not the answer. The answer ultimately is the value for X. So I need to take 73.74 minus 36.87. Right, to get 36.9 as the first answer. Second answer will be 180 minus 73.74, then minus again 36.87 for the second answer. Alright, so using the same method as shown in slide 4, we can also find the R formula if the expression given to you is A sine theta minus B cos theta. And in this case here, the R formula will be R sine bracket theta minus alpha. The formula to find R is the same, which is square root A squared plus B squared. And to find alpha is tangent inverse bracket B over A. Right, so sometimes the expressions can be expressed in the form A cosine theta instead. A cosine theta minus B sine theta. Right, so in this case here, then R formula will be R cosine bracket theta plus alpha. Why is it plus alpha? Because it follows your addition formulae that you've learned early on. If you were to recall, the addition formula for cosine bracket A plus B, that will give you cos A, cos B, minus sine A, sine B, right? And if it's cosine A minus B, then it's cos A, cos B plus sine A, sine B. Because the R formula is derived from the addition formulae, so we follow the rules that is observed in the addition formulae. Alright, so in this case here, what would be the values of R? Yes, the value of R is the same, which is just square root A squared plus B squared. And to find alpha is also the same, just tangent inverse B over A. Now, the next situation is the questions can also be given in the form A cosine theta plus B sine theta. So in this case here, the R formula will be equals to R cosine bracket theta minus alpha. Then how about the formula to find R? Yes, it's still square root A squared plus B squared. And to find alpha, it's still tangent inverse B over A. So depending on the questions, if you're given A sine theta plus minus B cos theta, that will be equals to R sine bracket theta plus minus alpha. If you're given A cos theta plus minus B sine theta, then the R formula will be R cosine bracket theta minus plus alpha. All right, let's do another example. So if you're given sine theta minus square root 2 cosine theta, you're asked to express as a single trigonometrical function, meaning you're asked to express it in the form R sine bracket theta minus alpha. This is what it means, right? So we're going to compare this with your A sine theta minus B cosine theta. Right, so from there, you can see that the values of A would be 1. And the values of B will be square root 2. Right, okay. It's very important to take note that the value of A and B must be positive. This is very important. Okay, so the values for B is square root 2, and it is square root 2, not negative square root 2. Right, so the next step is to find the values of R. So you plug in the values of A to be 1, values of B to be square root 2, and you work out to be square root 3. And to find alpha, will be tangent inverse B over A, which is square root 2 over 1. So it's tangent inverse square root 2. And that gives you 54.74 degrees. So express it as a trigonometrical function. Right. It will be sine theta minus square root 2 cos theta will be equals to square root 3 sine bracket theta minus alpha, which is 54.7 degree. Right, so that is our first answer. The second answer is to apply hence to solve the equation when it's equals to 1. Right, so if you were to look at what I've written here, the angle that I've used is 2 decimal places because this is the working answer. So working answer for angle in degree is 2 decimal places. But the degree of accuracy for the final answer for angles in degree must be 1 decimal place. Right. Okay, so equals to 1. So we're going to solve the trigo equation, make sine function is the subject, take 1 divided by square root 3. Right, so we have done enough of solving trigo equations to know that the next step is to find alpha, which is sine inverse 1 over square root 3. That gives 35.26 degree. And also we've done enough to know that the next step is to find the range, the new range given. Yes, of course, the ASTC, that's important because we need to seek out where angle X, angle theta is hiding. So it can be found in the first quadrant because your sine ratio is 1 over square root 3 is a positive value. Can also be found in the second quadrant. Right. And then the last step is you're solving for theta. So you have to take 35.26 plus 54.74 degrees. And why is it my answer is 90.0 degrees and not 90? Because all the while we have been using estimated number, estimated. All these figures are estimated figures. So it is not, the answer for theta is not exact 90. It's actually an estimated figure. And therefore, you should put it to one decimal place, which is 90.0 degrees. Then for the second answer, there is no dispute because you will get 199 point something something, and you can actually just round it up to 199.5. Right, let's look at this question. This one is highly challenging because there are actually 3 separate operations that you need to do. What are those? The first part is you need to express it in the form r sine bracket x plus alpha. So that will be your first mission. Then the second mission is to find the maximum and minimum values of the function. The functions refer to this. After you found the values of r and after you found the values of alpha, all right, this is your function. So you have to find the maximum and minimum values of that function. Then the third mission is after deciding the maximum value for this guy, all right, you need to justify the values of x. That means what is the value of x? X is an angle. What angle will gives you? That means what angle, when you substitute into here, will gives you a maximum value for r sine bracket x plus alpha. Right, so there are 3 things you need to solve in this example 3. All right, so let's start to fulfill our mission. All right, so first step is rather easy. You just have to express it in the form r sine bracket x plus alpha. Right, and you write now the value of a, which is 2, values of b is 1. Plug into your formula, which is square root a squared plus b squared, and you get square root 5. Go on to find your alpha, which is tangent inverse half, which is 26.57 degree. So we have done the first step. Right, so that is our first step. Mission accomplished. Yeah. Then the second step is to determine the maximum and the minimum value. So to explain how to get the maximum minimum values, I'm going to request you to recall your sine curve. Right? How does your sine curve looks like? Yes, your sine curve looks in the shape. Right. So to recall that, if you look at y equals to sine x, the maximum y value is 1. That means sine x, that means sine x is equals to 1 when your angle x is 90 degrees. In other words, sine 90 gives you 1, and that is your maximum value for sine x. And the minimum value for sine x is -1, and that happens when your angle x here must be 270 degrees. So these 2 information you have to remember it. And you will remember it after you do a few curve sketching. Okay? Right. So hence the maximum value of this guy here, the maximum value of this guy here will be 1, right? When what happened? When your x plus 26.57 must be equals to 90 degrees, right? Because sine 90 gives you 1, right? So if your sine bracket x plus 26.57 degrees maximum value is 1, then 1 times square root 5 will give you square root 5, which is the maximum value for this guy. And in order to get 90 degrees, your x then would have to be 90 minus 26.57 degree, which is 63.4. Okay, do you understand? If you don't, then please watch this slide a few times. Okay, so with that kind of understanding, we can go on to find the minimum value. So what do you think will be the minimum value of square root 5 sine bracket x plus 26.57 degree b? Yes, it will be negative 5. And that happened when this guy here, the minimum value is negative 1. Negative 1 times square root 5 gives you negative square root 5. And again, for that to get negative 1 means, what does it mean? It means x plus 26.57 must be equals to 270. So hence x is 270 minus 26.57, and that gives you 243.4 degrees. Right, let's do one example. Okay, right, so you're given 3 cos theta plus 4 sin theta. Right, so cos theta come first. So that will be equals to r cos bracket theta minus alpha. Right, if this guy is a plus, this guy is a negative. Plus on the left, then negative on the right. Okay, so what is the formula to find r? Oh, wait, hang on. Write down the values of a and b first. So your a is 3, b is 4. Right, how do you know a is 3, b is 4? You just compare it with your a cosine theta plus b sine theta. So your a will be 3, your b will be 4, right? What's the formula to find r? Yes. What's the formula to find alpha? Yes. Then you combine them, you would be able to express 3 cos theta plus 4 sin theta as a single trigo term equals to 5 cos bracket theta minus 53.1. Right, brace up. We're coming to the very near end of the whole video. Let's look at example 5. So it's not difficult. All right, we have already done a few questions on solving the trigo equation using our formula. So for this example 5, you should be able to do it with a breeze. All right, so the first step is to let 2 cos x minus 5 sin x equals to r cos bracket x plus alpha. All right, remember if you were to write 2 cos, if you write cosine x first position, then our formula will be cosine. And if this operation is minus, this guy here is a positive. Okay, right. Second step is to write down the values of a, which is 2, values of b, which is 5. Okay, a and b are always positive value. All right, so please don't write b as negative 5. Okay, b is equals to 5. They're both positive values. Then to find the values of r, just square root a squared plus b squared. And that gives you square root 29. And the values of alpha will be just tangent inverse b over a, which is 68.20 degrees. All right, so we have done the first part. The second part will be solve the equation, let it equals to 3.1. And as usual, we just go on to make cosine the subject, right? And then find alpha, which is very important, our dear alpha, which is a acute angle. Then go on to source out the quadrants where your angle x is hiding. So where is it hiding? If you do your, oh yes, you have to find your new range. Yes, in this case here, because you're solving for x plus 68.20, right? So the new range will be 68.20, between 68.20 and 428.20. All right, let's go on to find your ASTC. So where it's your angle hiding? Yes, it can be found in the first and the fourth quadrant because we are dealing with a positive value for cosine. Right, so first answer would be 54.85 from the first quadrant. And then from the fourth quadrant will be 360 minus 54.85. And remember, our new range is all the way to 428. That means you can actually go one more round. So how do you go one more round? Is to take 54.85 plus 360. Okay, right. Your first answer, 54.85, should be rejected. Right, because you see it's outside your range here, outside this guy here. Your minimum, it's 68.20. So 54.85 is outside. So it should be rejected. And then you can go on to find the remaining two. Right, so this is how we do example 5. Right, let's do one problem sum involving the R formula. Okay, let's look at the diagram. We are given a trapezium ABCD, right angle at 8 and B. AD is parallel to BC, right, and the acute angle ADC is theta degrees. All right, so we can actually separate your trapezium into a rectangle and a triangle, where I can have a right angle triangle there, and then the angle ADC given to be theta degrees. All right, I'm going to label the point there as point E. Right, so part 1, you're supposed to find the values, the length, express AB and BC in terms of theta. All right, so in triangle CDE, right, because this is a right angle triangle, we're going to use Tuakaso, right, to find the length for BC. Sorry, the length for AB first, right? So in triangle CDE, cosine theta would be, to find cosine is equals to A over the ratio of adjacent side over the hypo, A over H. So which is, if you were to label your diagram, this will be the opposite side because it's opposite your theta degrees. The longer side is the hypo, and then ED is the adjacent. All right. So it's equals to ED over DC. And to find ED, you just do a cross multiply. So ED is just DC times cosine theta. Okay. Right. And as what we have mentioned earlier on, okay, the reasons to find ED is because I need to find the values of BC. So can you see that BC is the same as ED, which you can be found by taking AD minus ED. So it's 10. The value for AD is given to be 10 here. So 10 minus 15 cos theta. All right. And then to find AB, we have to use still using the same triangle CDE, right? Used sine theta instead. So sine theta is equals to the ratio of taking the opposite side over hypo OH. So opposite is labeled as EC, hypo is DC. Again, you do a cross multiply and you would get EC to be 15 because the DC is given to be 15 cm, so it's 15 times sine theta. All right, so that is first part. Yeah, EC is the same length as AB. So therefore, AB is equals to EC equals to 15 sine theta. So that is the first part done. Second part is to find the parameter in terms of express it as the R formula plus a constant K. So to find the parameter of the trapezium, it's to add up all the different sides, which is AB plus BC plus DC plus AD, and plugging all the relevant informations. And you finally end up getting 15 sine theta minus 15 cos theta plus 35. Right? So your 35 is your constant K. All right. So what's the next step? Is to express it as the R formula. Right, which you should be very good by now. Okay, you can just solve it with eyes half closed. Not too sure about it. All right. Okay. So done for part 2. All right. So how about part 3 then? Let's look at the next. So for part 3, we're given the parameter to be 45 degrees. So using what we have found earlier on for parameter in terms of the R formula and the constant K, which is 35, we let it equals to 45. Right, so we solve it as per normal. All right, find our favorite alpha. All right, and determine the quadrants for sine, which is from the first and the second quadrants. Right, so if you look at the diagram, your angle theta it's an acute angle. It will be more than 0, less than 90, so you don't have to worry about angle from the second quadrant. We just have to take the angle from the first quadrant, right? So theta minus 45 is equals to alpha, therefore theta is equals to 28.13 plus 45 equals to 73.1 degrees. Alright, congratulations, we've finally come to the last questions, alright, of the whole video. But I would really encourage you to challenge yourself to solve these questions on your own. Alright, I can give you a little bit of hint. Alright, you're asked to show that AB is 3 cos theta plus sine theta. Okay, what are you given here? Are you given any angle theta? Oh yes, you're told that OP is inclined at angle theta with OA. OP is inclined, so your OP is here. It's inclined at the angle theta with OA. All right, so that means this angle here is theta. So if that angle is theta, this should be a right angle triangle, right? And you're asked to find AB, right? So we can actually form another right angle triangle here. Oh, your point B is directly, okay, this is very important. This is a very important information. Your point Q, it's vertically above point B. So it means your QB is a vertical line, hence this is 90 degrees. All right, so this guy here will be 90 minus theta. Okay, think about why that is 90 minus theta, and this will be theta. Right, and then you can just apply Torcaso. Okay, you can use Torcaso to find OA, use Torcaso to find OB, and then you add both of these up to get your AB. Right, you should be able to do it. I have confidence that you can do it, all right? And then OQ, it's 1 meter. You can just put in the data there. OP is 3 meter. Okay, so please challenge yourself, do these questions on your own, right?